Hey guys, welcome back to Calculus. Today we're going to talk about evaluating limits analytically. We've previously discussed how to look at them with numbers and on the graph, but this analytically, what I want you to think when you see analytically, you might think algebraically. All right, so we're gonna use the x's to figure this out. So there's a limit on what we can evaluate analytically. We're going to look at polynomials and rational functions. We're going to look at some trig functions, and then we're going to list some other strategies. Now, I can't get all of this done in 5 to 10 minutes, and so some of this we'll have to leave for class, but we'll have some ideas here. Okay, so let's look at two of them here. This is number one here and number two here. Well, when we have polynomials, and hopefully you recognize we have two polynomials here. You can't see me gesturing, but there are two polynomials here. We're just going to oftentimes plug them in. Okay, so I'm going to take this 2 and plug it in, and this 2 and plug it in here, so I get 7 over 8. That limit there is 7 over 8. Okay, let's check that on Desmos. We'll check it graphically. You could plug in numbers, but we're going to go to Desmos and check it. So here we have it listed already. And so right here, let's see if we can find where these intersect. It's not going to let me do 2. This is even 2.1. There's 2. And right there, we get 2 and 0.875. Hopefully you recognize that 7/8 equals 0.875. Okay. Now, so that's with polynomials and rational functions. Now, if I have a trigonometric function, most often what's going to happen there is we're going to plug that in. This is equal to the cosine of 0. And that's just equal to 1. Okay, so we're going to check here on Desmos. I think the magic of television just happened. But you'll notice as we travel from the left on this curve and from the right on this curve, they both come here to 0, 1. And so we're looking at the y value. The y value is our limit. That's 1. Remember, our x value was 0, and our y value is 1. Now, not all limits are that easy to evaluate, but for the most part, we're going to only do easy limits. Okay, so we're going to have some other limit evaluation techniques. All right, well, here we have a rational function. It's a fraction, so we're just going to plug the 4 in. So I'm going to have 4 squared plus 2 times 4 minus 24. Which is 16 plus 8 minus 24. That equals 0. That's poorly written. And apparently there's not a break here between these two fractions, but there we go. We'll make the break. Okay. And so then we get 4 squared minus 16, and that's also equal to 0. Well, so what we get is it goes to 0 over 0, which is something we refer to as indeterminate. Okay, this is a T right here, indeterminate. Okay, so we're going to have to do something else. So when we get this 0 over 0 case, this indeterminate case, we're going to have to start over. And I don't have enough room here, so I'm going to have to erase all this. Okay, and so here's what's going to happen. We're going to factor. So you guys all remember how fun that was in algebra to factor. Well, here is a practical use for factoring. So we're going to take the limit as x approaches 4. We're going to factor these two, and the numerator is going to become x plus 6 and x minus 4 over x plus 4 and x minus 4. Okay, And notice those disappear. And this is something that we've done in college algebra. It's something we should have done in algebra 2 also. But what I'm going to do now is I want to take a look at this blue function and this green function. Okay, so let's look at these two graphs here. Notice here they are. They're already graphed for you. But we don't see the black one. Well, when I take away the red one, we see that the red and the black are exactly the same. They're exactly the same. But let's do a little bit of investigation here. Let's go to 4. Notice on, let's see if I can get it. Hopefully you saw it flash through there. Notice on the black graph, 4 is undefined. Okay, I want to take the black graph away and I'm going to put the red graph in. But with the red graph at 4, we get 1.25. Okay, well, let's look at this analytically because we don't want to look at the graphs. So let's see what happens now when I plug in this 4 into here. So I get 4 plus 6 over 4 plus 4. That's 10 over 8, which equals 5 over 4. And for you intelligent calculus students, that's that y value of 1.25 that we just got. That's a very, very, very common evaluation technique for factoring. I'm sorry, for limits, we are going to factor. Okay, so sometimes when we have that indeterminate form, we can factor and we'll find our limit. Okay, so there are a lot more that we're not going to put on this video. We're going to discuss these all in class, and I'll show them all to you. Okay, so we have what's known as the squeeze theorem. Okay, we'll do a few exercises with those. We will rationalize. Okay, with radicals. So hopefully you remember how you rationalized in college algebra and algebra 2. And then we're going to look at 2 special trigonometry limits that will help us out.